Alright, so now we're going to try to figure out what allele goes where on a chromosome. And you'll notice here we have something called a genetic map. And what a genetic map basically does is it shows where each allele is on each chromosome. And an important distinction to make here is that all of these are 50s. I kind of modified this chart a little bit. And when alleles are 50 centimorgans away, centimorgans are a unit for how far away alleles are from each other on a chromosome, and it's also the same thing as what percent of the time they'll recombine. So percent recombine. And this goes into crossing over. But basically, when it's 50, you know that they're going to be on different chromosomes. So here I drew two lines, and they're supposed to signify a chromosome, a very basic chromosome. But we know that G1 and TP2 must be on different chromosomes from the rest of the alleles because they're 50 away from everything else. So the way to read this genetic map is from both sides. They didn't bother to fill out the rest of the map because it's kind of redundant because it would just be these values. So if you start from here, you'll see G1 is 50 away from R1 and MS10, and TP2 is 50 away from R1 and MS10, and the same thing for down here. Except for when it gets to the crossover of G1 and TP2 because it's only 2. So you know that they're on the same chromosome, but they're on different chromosomes from LN1, MS10, and R1. So let's put them on this chromosome. And I don't think size matters either. I just made it smaller because there's less alleles on it, but literally does not matter at all. So we know that G1 is on this chromosome and TP2 is also on this chromosome. And we know that the distance between them is 2 centimorgans. Awesome. So now that we've figured all that, we can basically just ignore this, that, and that. And now we're left with this information. So, because none of these numbers are 50, they're all on the same chromosome. And you'll notice that these two numbers add up to 34. So that must mean that MS10 must be in between R1 and LN1. These problems are kind of fun because they're sort of like puzzles where you have to fit the missing pieces onto the chromosome. So, the biggest distance is between L1 and R1, and that's 34. So let's put them on either ends. Let's say this is Li1, and there's a distance of 34 centimorgans. And then in between them should be MS10. But which allele is it closer to? Is it closer to LN1 or is it closer to MS10? Well, since the number of centimorgans between MS10 and L1 is smaller than the number of centimorgans in between R1 and MS10, we know it's closer to MS10, or closer to Li1. So it should be around here, MS10. So this is 10 centimorgans, and this should be 24 centimorgans. And you'll notice that it adds up. 24 plus 10 is 34. Sometimes these problems try to trick you, and you might be putting an allele out here. So it's very important to notice how these measurements add up to each other. Because say, for example, it was only 10 centimorgans away from Li1 and you thought it was inside, but then it was 44 centimorgans away from R1. Then it would be to the right of Li1, not to the left. So these sort of distinctions make it a little tricky, but as long as you take it slow, as long as you realize which alleles should be on a separate chromosome, you'll be good. Also, just a little note, these aren't drawn to scale because the 2 centimorgan is sort of bigger than the 10 centimorgan, but yeah. That is how you figure out which allele goes on what chromosome using a genetic map.
Ooh, it's the end screen. Click on one of these links to be directed to that playlist. And don't forget to subscribe!